Hello and welcome to Joe and Paul's Another Mining Podcast with me, Paul Harris, and Joe Mazumdar.
Hey, Paul, how's it going?
Very well, very busy week. Lots going on, third quarter results, COP26 in Glasgow. And with that as the theme this week, I have great pleasure in introducing our guest, Mark Fellows, co-founder and CEO of Skarn Associates. Hi, Mark.
Hi, Paul. Hi, Joe. Thanks for having me.
Yeah, COP26 in Glasgow about climate change and what governments and the world leaders are doing about that. Mining's an element there. Mining's going to, on one hand, provide the materials that a lot of people think are going to be needed to fight climate change, decarbonisation, electrification, that kind of things. And mining is also a source of greenhouse gas emissions in and of its own right. So we're going to get into that with Mark. Skarn Associates is making a name for itself for the past couple of years. By producing carbon curves about mining operations for various different metals, including aluminium, copper, gold, iron ore, and some other things besides. Mark, perhaps start off by telling us a little bit more about Skarn and what you do.
Sure. Thanks, Paul. We're a young business. Although we've been in existence for about 4 years, it's only over the past 2 years that we've refocused ourselves to look at the connection between ESG and mining, and we look at that in a very analytical, numerically driven way at the mine by mine level. And the background is that all of us involved in the business are mining analysts, so we're mining industry people. Between us, we've got a lot of experience looking at mining operations, but previously looking at the economics of the industry. So we've all got backgrounds with businesses that are really known for creating industry cost curves and those kind of mine by mine economic analyses. But we realized that the big strategic issue facing the industry over the next 10, 20 years is going to be energy and the low carbon transition, and also a whole bunch of other ESG related topics like water, land use, biodiversity. And many of those things actually lend themselves to our kind of mining analysts' numerical approach. If you look at carbon emissions, they're driven by energy inputs. If you understand the mining method, the process method, the scale of the operation, where's the electricity come from, you can actually benchmark all those things. You can then turn that into a carbon emission estimate, and you can then reconcile those things with the numbers that companies are reporting, because obviously companies are now widely reporting their carbon emissions and in some cases their energy inputs as well. So our business is really about doing that. And so far we've covered around 2,500 assets across 9 commodities, which is probably 500-600 companies owning those assets. And we've put those together into a bunch of greenhouse gas intensity curves for each commodity, which are becoming increasingly the industry standard, I think it's fair to say, amongst the particularly the major mining companies. But it's also, we've had a lot of uptake with the smaller guys too. The financial institutions, royalty companies, governments, all of them are consumers of our work now.
So I remember, Mark, from when I worked for Newmont and before that Phelps Dodge. Mark worked, I believe, with Brooke Hunt, and then with the onslaught of Brooke Hunt, and the way they did it was understand how many liters of diesel you use, how many kilowatts of hours of power, and blah blah blah, and all of that goes in, not into your cost anymore, though it would, but now into your carbon equivalent emissions. But you had, like before, a C1, a C2, and a C3 cost in terms of cash costs for companies, and now you've generated a different costing schedule for mining companies. So could you go through, your clients, so how do you look between these different cost profiles, or carbon equivalent emission profiles?
So we have come up with our own in-house metric, which we've designed to be reflective of the way the mining industry's supply chains work. And we call it our headline metric, we call E1 rather than C1. And E1 is based on the very widely used now GHG protocol methodology, which is, you'll hear people referring to Scope 1, Scope 2, and Scope 3 emissions. So we're building on those Scope 1, Scope 2, Scope 3 classifications. But what we're doing is we're drawing a boundary in our numbers, in our reporting, which covers the whole mining operation from rock in the ground through the mining process, the on-site ore processing, in the case of the base metals, the shipping of the concentrate to the smelter, the smelting and the refining, all the way up to refined metal. So that's the E1 reporting boundary using our methodology. And in the GHG protocol terms, that includes components of Scope 1, which is your mine site fuel usage, so mostly diesel in effect. Your Scope 2, which is your purchased energy, which is effectively electricity, and your some components of Scope 3. So Scope 3 is the stuff outside your boundary of control as a miner, and in our case, that refers to the freight and the concentrate freight and the smelting and refining. So we refer to that as E1, and we produce a bunch of commodity-specific carbon intensity metrics for each of the commodities, which we can then plot up as curves, which look similar to cost curves. Along your horizontal axis, you have production, and each bar within the curve it represents an asset. We rank them in order of increasing carbon intensity, which is the vertical axis. This thing's easier to look at than explain. And then you end up with a curve, and you can say, well, okay, my mine is very low carbon intensity. It sits in the left-hand low carbon end of the curve. Or my mine is high carbon intensity. It sits on the right-hand side. And we, typically miners will buy our products to show where their operations sit on the curve, and also demonstrate how they're going to hopefully move them down the curve as they decarbonize. And likewise, the financial institutions use this as a way of representing where assets they may be considering investing in or promoting an M&A deal involving where they sit on the curve, and obviously to try and benchmark their transactions, their portfolios.
So I'm seeing a lot more of these sort of curves. And it's typical of any mining company when they put out a presentation. If they have low costs, they'll show you a cost curve. If they're high grade, they'll show you where they show on the high grade part. If they don't show you one thing, it's because they don't have it. But the guys that do have and then show up in the lower quartile of your curve, they'll publish that figure. So if we go into Scope 1, are all companies the same in terms of mining assets, in terms of the trucks and the mining activity? There's not much comparative advantage in Scope 1?
What tends to differentiate companies or mines from one another with regard to Scope 1? Obviously, there's a big difference between underground and open pit operations.
Okay.
And open pits can be very, underground mines, it can be very variable. You get some underground mines which have a relatively low diesel consumption. They're mostly electrified. You can have some which are actually very high. They might have a very extended underground infrastructure and be using lots of mobile equipment underground and trucking up a decline ramp. So, it just really depends. In the case of the open pit mines, what drives their carbon intensity, their Scope 1 carbon intensity, how much diesel they use, is essentially the strip ratio, the scale of the mine. Obviously, you get some advantage from using very large trucks as opposed to small trucks in terms of the fuel consumption per ton of rock. Haul distances, how far away from your pit is your waste dump or your process plant? Are you using an in-pit conveyor, crusher and conveyor?
Yeah.
That can have a big influence. But also, when you look at the intensity, the carbon intensity per ounce of gold or per ton of copper, the big driver is grade. If you've got a low-grade mine, you're going to be mining and processing a lot more rock per unit of gold or copper or nickel output. And so consequently, that's a huge driver of the carbon intensity per ton of metal
So
output.
let's take that just to some examples. And so, when we look at a remote project in a place that requires diesel or heavy fuel oil or what have you, versus a project that's much lower grade but has hydropower, um, how do you quantify that? Because even though it's hydropower, they have to move a lot more material than something that's higher grade, and so that all comes out in your E1.
It does. So you'll find you could have, and what you're describing there, if you've got a low grade mine, but it's has the advantage of hydropower, what you might see there is its scope 1 emissions are relatively high
Yeah,
because it's using a lot of diesel per ounce of gold production or pound of copper, but its scope 2 emissions, as in its electricity carbon emission, will be very low
right.
because obviously hydropower has a almost negligible carbon output per kilowatt hour of electricity. So you end up with a very sort of heterogeneous population in terms of that mix between scope 1 and scope 2 emissions.
Can I sort of jump in there? I mean, it's obviously very difficult to retrofit an existing mine and change how it was designed and planned to take on board this new paradigm, this new way of viewing the world. But obviously, for future mine developments, this is going to be the case that you can perhaps factor in the use of different equipment, taking advantage more of hydroelectricity or whatever. You can plan your haul routes differently, maybe to use trolley assist. But are you starting to see these kind of things coming through in mining plans and what companies say they're going to do and how they're going to do it? Adjusting to this
Absolutely.
brave new world.
Absolutely, and even smaller companies now are considering quite fundamental changes to their mine design and their mine infrastructure to install things like trolley assist or conveyor systems, and obviously things like solar arrays, wind farms, all of that stuff. But this is going to be one of the really fascinating knock-on effects of decarbonisation. And it's going to have a real root and branch impact on the way mines operate. And mines are going to be optimized at the design stage for a whole different set of parameters, because traditionally your engineering consultant would optimize your mine plan to maximize the NPV, or at least that's what they were supposed to do. Quite often they'd be optimizing your mine plan for the chief executive's idea of what was best for the share price. I would argue, which that's a different conversation. But what will happen in future is mines will be designed wherever possible for things like your ore haulage to be, so when your trucks are loaded, you'll want them to be traveling downhill rather than uphill. Now, obviously, that only works if you're mining somewhere with that elevation difference, and you're taking, an ore body that's perched on top of a hill. That's going to be very advantageous. But there's also going to be a lot of changes in terms of power infrastructure. Mines are going to need mines which currently have not connected to the grid, but which for whom it's an option. We're going to be wanting to connect to the electricity grid. Mines which are already on the electricity grid are probably going to want to double at least their electricity consumption. So they're going to have to upgrade the infrastructure to facilitate that. If you're going to be putting in something like trolley assist or conveyor systems, you could well be redesigning the whole mining schedule. It's going to have real root and branch impact. And the other big kicker here is that for many operations, particularly those with short mine lives or for which the economics are already a bit marginal, they're not going to be viable in terms of decarbonisation. It's just not going to make sense to spend vast amounts of money buying hydrogen fuel cell or battery electric haul trucks if your mine life is restricted to 5 years. You really need probably a 15-year mine life to justify it. And many operations do not have that. And obviously the pressure that they're going to be under is going to come through carbon taxation, through investors disinvesting, because many of the big institutional investors will have a mandate to disinvest from companies that aren't decarbonising rapidly enough. And this is going to have a massive impact. I mean, ultimately, it's going to have a knock-on effect on the availability of supply and on the balance between supply and demand and commodity prices. So we're looking at something that's going to have a massive impact on our industry over the next 20 years.
And imagine
So-
specifically in gold, because gold mine lives tend to be shorter than, let's say, a copper mine life. So that could really put the cat amongst the pigeons there.
And if you've got a very narrow, vertically dipping ore body, it's just not economically viable to drill 10 years ahead worths of reserves. It's just not geometrically possible in some cases. So what do? It's going to be very, very interesting. And then add to that, I mean, obviously copper is part of the decarbonisation solution as a commodity. It's going to be in, demand growth, massive demand growth, just to put in all that electrification infrastructure, but that the world needs. Gold is a more discretionary product, and there's already, many decades worth of physical consumption sat in bank vaults around the world. There are a lot of people out there might be thinking, well, an easy way to cut the carbon emissions from gold is to stop mining it. So the gold mining industry is going to be under a lot of pressure to be at the forefront of decarbonisation. And I think that penny is starting to drop. Actually, I really do. I think many of the more progressive thinkers in the gold mining industry are starting to realise that.
So when I worked for Newmont, electrification was a big deal, to get on the grid. But the other problem is that might help you maybe at one part of your cost, or sorry, your carbon emission, but then it might hurt you later because the power might be derived from, fuel, natural gas, or coal power. And you see that on the emissions and the scope scope 3 emissions from Chinese producers, but also when they talk about electrification in Nevada, because a lot of that is natural gas and still some coal there, that they don't look that good even if they electrify their trucks.
No, you're absolutely right. And it's kind of a similar situation to we have here in terms of the power supply in the UK generally. We had a big switch over from coal to natural gas back through the course of the 80s and the 90s. And that's given us a bit of a head start on decarbonisation. But the next phase has to be moving away from gas too. And Nevada, as you say, is still in transition from coal. Those big power stations that serve the coal-in operations, they're in the process of switching those over, or at least partly over, to gas. But there's another transition yet to come. And the real kicker for those Nevada gold ops is they're also very energy intensive, because you've got a lot of refractory material. Yeah. It's going into autoclaves, it's going into roasters. You've got some underground mines there that are fairly power intensive as well. The open pits are pretty big and the strip ratios are pretty high. So consequently, those things plot up at the high end of the carbon curve. And decarbonising them is going to be kind of expensive. But at least, we could talk an awful lot about the pros and cons of exploration too far in advance of production in Nevada. But that's going to be one of the decisions. Is it worth investing all of this money? I'm sure it will be, but it's an interesting conundrum.
One advantage with gold is that it produces almost the refined product at site, and so your scope 3 emissions don't apply to gold and silver usually, unless it's in a concentrate. But so scope 3 is when you really start tacking on the smelting, refining, the freight. And so how does that look like? And that's something that hard to control for a mining company who doesn't want to be involved in the smelting business.
It is. And if you look at something like copper, um, those downstream emissions, so the emissions associated with shipping that concentrate offsite and the emissions associated with smelting and refining, account for, I think, something like 35% or thereabouts of the total emissions through to refined metal. And as you say, the miner does not have control over those things. The only control the miner has is in maybe having some choice of which smelters to send the material to. But that choice is fairly limited in reality, in that most of the smelting and refining capacity has become concentrated in China. And China is predominantly coal-fired power. And this issue is a massive one when you look at, say, aluminium, where over the last couple of decades, we've seen huge growth in aluminium smelting capacity in China and a huge growth in coal-fired power stations to supply those aluminium smelters, which are essentially just huge electricity freezing factories. And, consequently, the carbon emission associated with aluminium just dwarfs the rest of the mining sector completely. And until China gets a real go on decarbonising its coal-fired power stations, that's not going to change. So much really does hinge on China.
I mean,
Yeah,
it's
because
interesting,
it
isn't it?
controls the
Because
downstream.
obviously, aluminium is one of the, as with copper, it's one of the infrastructure materials for transmission of electricity.
And it's a lightweighting material. If you want an efficient car or whatever it is, use lots of aluminium because it's more energy efficient to drive around. So yeah, absolutely.
The other problem I see is that there's this gap in terms of where we want to end up and where we are right now. So the problem is that if we capital invest for a world that we foresee in 2030, 2050, but the reality of the world right now, and I see that in the coal industry. So even though we're all negative about coal or energy, oil and gas, those are the commodities that are doing the best right now, because nobody wants it, but they still need it.
Yeah, it's
Yeah.
true. And as you say, what happens if you just stop investing in fossil fuels right now? Well, obviously that just can't happen yet. So yeah, we're in a really interesting transition, and I think if you the scary thing is, and this was the kind of epiphany I went through, was I actually took the time to read some of the science and realized that actually we are genuinely on a path towards the higher end of the projections in terms of global warming. And we're also facing a really difficult task if we are going to decarbonize. You realize we are really in a very tight spot here. But on the other hand, you have to have some hope that humanity can sometimes do surprisingly positive things very quickly. And I think we're at a really absolutely pivotal moment right now. And it's going to be very interesting to see how the next few years pan out. And I know everybody's very alert to the fact that COP26 may be mostly greenwashing, maybe mostly companies just saying one thing and doing another. Completely agree. But I don't think that can continue forever. It can't. And the really progressive companies are seeing the opportunity here. And there is an opportunity. These things do actually start to make economic sense. And obviously increasingly so as decarbonising technologies get some scale to them. They become cheaper. And already many of these technologies with application to the mining sector, we're starting to get to that point. You can see how the economics will make sense. It's just going to be tough on some of those marginal mines with short lives. So
I think you can see that very much in the scope too. A lot of mining companies that are switching out to sort of renewable energies, they're doing it because they're reducing the scope too, but they're also getting reduced costs with that as well.
And in many jurisdictions, switching to a renewable grid power supply through a power purchase agreement, it's actually no more expensive, or it's even cheaper than being anchored to a coal-fired power producer. So, these technologies they're scaling and they're coming down in cost.
All of this is obviously going to be already starting to make an impact in many, many different ways. Certain jurisdictions are starting to implement carbon taxes. British Columbia, for example, is one of the sort of leading jurisdictions there. And are we approaching a time when we start seeing sort of carbon costs appear in company quarterly results, balance sheets, that kind of thing?
We are, for sure. We're already hearing this from clients. And in the case of some of the Canadian producers, they're concerned that carbon taxes are ultimately going to be, 25–30% plus of their cost base. So yeah, it's gonna have a real impact.
Okay, and so obviously one mechanism to reduce, on paper at least, sort of carbon emissions, buying carbon offsets. Do you see that is that a long-term fix, a short-term fix? Is that just companies trying to dodge the issue? Will investors clamp down on that and say, you got to come up with a better solution than just buying credits, offsets?
There's a lot of skepticism out there. I'm talking about the world at large now about offsets, and I think quite rightly so. And even the reputable companies selling offsets are saying, you know what, we're not selling you this as the permanent solution. We're selling you this offset as something that will reduce your stated CO2 emissions while you get your act together and permanently decarbonize. And I think there's a fairly widespread recognition that is the role, if you like, of offsetting, and that it's just not feasible to plant enough trees in the world to really be a long-term solution. So yeah, and there's all sorts of issues around the credibility of individual offsets. Who signs off on those?
Yeah.
Are they fundamentally sound?
It becomes a bit like a cryptocurrency.
It does.
Yeah.
Well, yeah, exactly. I think that's a good analogy.
So just to wrap up, like, how do you think, like, you've got like a client base, you were telling you, of just not only producers but developers, and then also across industries, aluminum, gold, base metals, blah blah blah, and then also you're getting the investors that invest in these companies. And so are they all looking at it from different perspectives, or are they all just looking at how do I look at, this one's high, so no, this one's low, so good. But that's only one lens, right? Or is that the lens now?
We are genuinely seeing carbon intensity and position on the carbon curve becoming one of the factors that's taken into consideration when banks look at financing something, when the institutional investors look at buying into something, when companies look at a potential M&A transaction. They're taking this into account. So it's material from that point of view. Then there's obviously the reporting issue with TCFD and companies being required by the exchanges to actually report their emissions, and in some cases to put those in the context of their competitors as well, and are you higher than lower than your peer group? So yeah, there's various, it's not just one driver. And then you have, the major mining companies, they're obviously, they work on long time scales, and they think about strategy in a lot of depth, as you know, Joe, from your career. You know, your job is to look 30 years into the future, look at the assets we have, the assets we may have, and this is one of those factors that's now being planned into that stuff. Is, well, you know, how are you going to decarbonize it? Is it gonna stick out in our portfolio as something that we, you know, we're struggling to decarbonize, and how's that going to play with our investor base? So yeah, it's genuinely being you know, taken into account from lots of different angles now.
Okay, Paul?
No, that's I think that's all from me. I think you know, it is going to become an increasingly discriminating factor. I guess from an investors, they want to back the right horses, and so capital will flow to the best horses, the best performing ones, both financially and increasingly on an environmental performance.
I would guess on the capital asset allocation basis, as Mark is talking, like it will impact investment decisions, M&A potentially going forward, because
Cost
like
of
you look at
capital
it,
as well.
yeah, and then we see a lot more of these ESG bond links that companies are taking on. And so obviously what Mark's doing and other independent analysts are doing is going to weigh in on how they actually, you know, it's not just about where you sit on that curve, is where you're going to sit on that curve as you within that bond time frame. So a lot of interesting things from a capital asset allocation and potentially decisions going forward. More uncertainty for the mining industry. But if we taper production, then that can only be higher commodity prices, I would think.
Well,
Yeah.
Very interesting times, and I think you're right. In many ways, the future outlook for commodities is very positive. Price is probably going to continue trending up. Lots of challenges, but the mining sector always has lots of challenges.
Yeah.
Okay.
Yep.
Well, this has been a fascinating discussion about us. You know, the new paradigm that's here with us now and is going to continue well into the future. So, thank you very much, Mark Fellows of Skarn Associates, for joining us.
Thank you for having me, guys. Really enjoyed it.
Joe Mazumdar, and I'm Paul Harris from Joe and Paul's Another Mining Podcast.